Sodium chloride, aka salt. How can we make it? Well, this sample here was made by dehydrating salt water. Of course, the sodium and the chlorine ions exist within the water dissolved, and you take the water away and you leave these lovely crystals. But can we do one better than that? Can we manufacture it from the raw ingredients, sodium and chlorine itself? In order to do that, we need sodium and chlorine, and this is how we can do it. The sodium is easy because you can buy solid sodium, and here we have some stored in liquid paraffin to stop it reacting with water. Now that's the first, but getting the chlorine is a little bit more difficult. And the way that we have to do it is we have to take hydrochloric acid, which I've got right here, concentrated, and we're going to react it with potassium permanganate. Now, what this is going to do is the potassium permanganate, a very strong oxidizing agent, is going to oxidize the chlorine into its gaseous form, which we're going to try to capture. Come and have a look at the apparatus that I have in this fume cupboard, and I'll show you how I do it. I'm going to place potassium permanganate in this Buchner vessel, and I'm going to use this thistle funnel in order to create an airtight pocket, kind of like the U-bend of a toilet, so that any gas that is produced by this reaction is going to be forced out of this side tube into a gas jar. Now, it's very important in this reaction that we use hydrochloric acid with potassium permanganate. Sulfuric acid will result in explosion, and that is not what we want, so it's best to double check. I'm going to set this up and show you the production of chlorine gas. The first stage is I'm going to put the potassium permanganate into this Buchner jar. There it goes. Then I'm going to pour out some hydrochloric acid. There we have it. I'm going to use some mineral wool to stop the gas escaping, but I'm going to use also some blue litmus, slightly damped. And that should bleach if chlorine gas appears, and we'll leave it there. And this would also change colour. So the first stage, so I'm going to put the thistle funnel in, and I've got the fume hoods fans running because this obviously chlorine gas is hazardous to breathe. So we're going to go with the reaction. Let's see what happens. So you can see the yellowy gas, chlorine. It's now also appearing down here as well. I'll take you in closer to have a look. You see the chlorine gas filling up this tube just here. So what I'm then going to do, I'm going to remove the mineral wool. What you can see is that the litmus paper has bleached white, positive test for chlorine gas. So what I'm going to do, straightforward way, is put a lid on it, and I'm going to leave that just there. So now I have produced a sample of chlorine gas onto the next part of the experiment. The next stage is to react it with sodium. So I'm going to take a piece of sodium, metal it onto a bigger piece. And now for the really fun bit. I'm going to turn the light off. I'm going to use this little portable Bunsen burner to set fire to this sodium metal. And then I'm going to tip chlorine over the top and look for the production of sodium chloride. low of sodium there. Okay. Then we go with the chlorine. Final stage is we're going to allow this gas to vent, and it's very, very smelly, so we tip it upside down, lower the fume hood right down, let it vent out. You can see a little volcano just there, inside a ring of salt. There we have it, a ring of sodium chloride made from sodium chlorine itself.